So in lesson 3.4, we're going to begin to take a look at atomic structure as we currently understand it.
Yep, and the objectives are to describe the charge, mass, and location of the three subatomic particles.
We will then define atomic number.
Define the mass number.
And then we will show you how to determine the number of protons, neutrons, and electrons in an atom, as well as I believe we cover how to represent different isotopes in a couple of different notations that we've come up with for representing them.
All right, and your reading for this is in Chapter 4, pages 98 to 102. All right, so the subatomic particles that we know about now are the electron, the proton, and the neutron. We're going to describe the charge, their mass, and their location. So for the electron, the charge is -1. Its mass, for all intensive purposes, I believe is 0 AMU. We pretty much ignore the mass of the electron.
It's so small as compared to protons and neutrons, it's insignificant.
It's over 2,000 times smaller since we, know the mass of it. And then the location of the electron, of course, I guess we want to be the most specific and correct, would be the electron cloud, is where we want to say the location is. We haven't talked about the electron cloud yet, but it is in the most modern atomic theory that they mention the electron cloud.
So it's outside of the nucleus for the most part and in the surrounding area around the outside of the atom.
Exactly. But once we start talking about quantum mechanics, you'll find out some interesting stuff about the s orbital and the electron, but it doesn't matter. All right, the proton, its charge is +1. Its mass is 1 AMU. I didn't say it before, but AMU stands for atomic mass unit. It doesn't weigh it in grams. It doesn't weigh it in kilograms. It's its own unit.
In grams, it's like
1.6 times 10 to the negative 24th grams. Or 27th.
But because that's such a small number, we just invented our own unit for talking about atomic size masses, and since protons are units, we just said, let's make a proton 1.
Exactly. And its location, of course, is the nucleus. Not the cell nucleus, but the, atomic nucleus. And then there's the neutron, whose charge is 0. Its mass is also 1 AMU. If I'm not mistaken, the mass of the neutron is slightly higher than that of the proton.
Teeny bit higher, but
okay.
But it's close enough to 1 we can consider them.
And of course, its nucleus is also, its location is also the nucleus. Let's try to speak correctly.
You will occasionally, in some texts, see that those two particles, the ones in the nucleus, referred to as nucleons, because they reside in the nucleus. Okay, on to some periodic table stuff.
All right, so to determine the number of protons and neutrons in an atom or an element, we need to know something about the periodic table. And on to the right there, you see carbon. It has number 6, the C, which is the elemental symbol, and then 12.011, which is its average atomic mass. And using all that information, we can determine quite a bit about an element. So the first thing we're going to talk about is the atomic number. The atomic number is the number on the top there, above the C. You will find that number randomly on different locations for different periodic tables. Just know the atomic number is always a whole number, and that it always tells you how many protons are in that particular element. So if we look at carbon, you can see that carbon has the atomic number of 6, so therefore we know it has 6 protons. We also can then say, if I have a neutral carbon atom, how many electrons would it have? So if I have a neutral carbon atom, Mr. Ferguson, how many electrons should it have if it has 6 protons?
6 electrons.
All right. So let's take this one step further, and let's say I had a negatively charged carbon, which means it has an extra electron on it. So how many electrons should I have?
It's going to have 6 plus 1, 7.
7, okay. We'll talk more about charge states later, but I just want to make sure you understand that this is a potential way of finding the number of electrons. So the next thing would be the mass number.
Can I just interject one thing, because I think it's an important point?
All right.
the defining characteristic for an element is its atomic number.
Yeah,
so
it's number of protons.
that we're going to see that the number of electrons can vary for a given element.
If I took all the electrons off of carbon,
it's
it would
still
still be
carbon.
carbon.
And the number of neutrons is going to vary, as we're going to see in a moment, or can vary. But the number of protons is what defines carbon as carbon. So if it doesn't have 6 protons, it's not carbon. It must have exactly 6 protons. So the atomic number is the identifying feature of any element.
So the next thing we're going to look at is the mass number. The mass number tells us one very important thing. It tells us the number of neutrons in that element. So if you look over...
No, it tells us the number of protons plus neutrons.
Well, yes, but... Yes. Fine. What he said. It's the number of protons plus the neutrons for that particular isotope. So if you look over at carbon, 12.011, that is an average atomic mass, which we'll talk about on the next slide. But if you just look at 12 as a whole number, that's telling us there are 6 protons, because the atomic number is 6. You take 12 minus 6, and that would tell you how many neutrons you have. So in this case, if your atomic mass number, or your mass number is 12, and your atomic number is 6, you know you would have 6 neutrons. So that's your math so far. It's pretty easy.
Subtraction.
So, yeah. And then we're going to get to a little bit of multiplication a little bit later, but it's all 3rd grade level math. I hope we can take care of that. So a word that I mentioned a few seconds ago was the word isotope. Notice the atomic mass of carbon is 12.011. An isotope is any element that has the same number of protons in the nucleus, but a different number of neutrons. So in the case of carbon, you have carbon 12, which has 12 total nucleons, and then you have carbon 13, which has 13 total nucleons, except for it's still 6 protons, but in this case it would be 7 neutrons. So that would give us the total number of nucleons in it, and elements can have anywhere from 2 isotopes all the way up to like 50, depending on its size.
Right. It seems like the heavier the atoms get, the more possible.
But there does seem to be a magic number of neutrons. You can't have any combinations of neutrons and protons. If you take a look, you can usually find that there's certain, this number of neutrons and this number of protons are good.
So for carbon, like Mr. Hunter said earlier, you can see that it's pretty close to 12. So a good guess for an element like that would be if it's just slightly more or slightly less than a whole number, then
the majority of that is that whole number.
That's
so
probably the mass number of the most common isotope.
Now, if it was like 12.5, you would have to assume that it's like a 50-50 mix of something. But 12.01 to me would indicate that the majority of the isotopes are 12 grams per mole, and a very small minority is 13 grams per mole. So let's take a look at how to calculate these. Alright, so before we can talk about how to calculate the average atomic mass, we do need to understand how scientists would talk to each other in a way that they can easily transfer information about the number of neutrons, protons, electrons in every element. So the first type of notation for doing this is one known as hyphen notation. So if you're looking back at the carbon element again, it was atomic number of 6. It was atomic mass of 12.011. And to do the hyphen notation, you do it one of 2 ways. You either write the elemental symbol, C, and then the hyphen, and then the number of protons and neutrons combined. So as you see, Mr. Ferguson has wrote C-12 or carbon-12. That is telling you we are talking about the carbon element that has 6 neutrons and 6 protons. But if you wanted to convey the idea of carbon-13, you could then write C-13 or carbon-13. That way, the reader would know that he or she is dealing with a different isotope of carbon.
And they don't come out and say carbon atom with 6 protons, 6 neutrons, and 6 electrons, because it's a shorthand, and anyone who understands the notation and has access to a periodic table should be able to figure the rest of it out.
Exactly.
That's kind of the
And then the other type of notation, which is actually more common, is known as nuclear notation or atomic notation. I'm sure they're referred to both ways. So you would still use the elemental symbol C, and in the top left-hand corner, you give the total number of protons and neutrons. So for
that's
carbon
the mass
12,
number.
it'd be carbon 12, and then on the bottom left, you would put the number of protons, or the atomic number, which would be 6. And then the other version of that would be carbon 13. So it'd be C13. There you go. And just so you see another example, let's do oxygen instead. Oxygen's elemental symbol is O. It is a mass number of 16.
Most common isotope is 16.
And its atomic number is 8. So there's that. And I believe the other one is... you don't know the other isotope number. I think it's 15. And that way you can see you can do this with any kind of isotope. And of course, a more common would be hydrogen, but you don't really need to see another one, I don't think. They're pretty straightforward. We'll have quite a bit of practice in class the next day with these. They're very straightforward, and you'll catch on quickly. Alright, so we're going to look at some examples of these different types of notation. So at the top left, you'll see Li-7. So what are we going to do there, Mr. Ferguson, that you want us to do?
First of all, to do these, make sure you have a periodic table here so you can look up little tidbits of information that you might want about your element. So I know it's lithium-7. That tells me it's got 7 particles in the nucleus.
Yeah, so we're going to put this into nuclear notation, correct?
Well, we're going to identify how many protons and neutrons and electrons.
So the number of protons we can pretty much automatically say.
Oops.
You can go ahead. I just clicked it for you. There you go. We can pretty much say that the number of protons is going to be 7 because the atomic number is 3.
It's going to be 3.
Duh. Sorry.
Protons is 3. So where am I looking? I'm looking at my periodic table, and this version, there's the atomic number
Let
right
Mr.
there.
Hunter screw up for you.
That's all right.
So then that means if we have how many neutrons then? I'm going to go to next. So
the number of neutrons is going to be 7, which is the mass number, or the total number of protons and neutrons, minus
Okay, I see where
3
you're going. He's a tricky person.
Which is 4.
All right, and of course the number of electrons in this would be, if it's a neutral, would be 3.
3.
Okay,
So-
and I guess then we'd want to take this one more step, and let's change it to the different notation while we're at it.
Okay.
So we will have Li as our base. We know the mass number, or atomic, the mass number is 7. The atomic number is 3. So this is a skill you do need to have and be able to do. So let's do a similar thing to lithium-6.
So this is another isotope of the same element. So one thing I could tell is that the number of protons, I don't even have to look because I know it's lithium. Lithium's atomic number is 3. Regardless of its mass number, it's going to have 3 protons. Now my number of neutrons is going to be the mass number, again, minus the atomic number. 6 minus 3. So this one has 3 neutrons as well. And for the same reasons that the first lithium had 3 electrons,
The neutral lithium will also have.
lithium-6 is going to have 3 electrons as well.
And then the difference for its atomic notation is going to be Li-6-3. Alright, so let's look at the third example here. We're telling you that this object that we're looking at has 20 electrons, 20 protons, and 20 neutrons. We would like for you to give us the element and its
And then write it in the
symbol.
right notation.
So we have 20 protons, so let's find one that has 20 protons. Look at our periodic table over here. We have 20 protons, that we're looking for an atomic number of
Now, this
20.
can be tricky because there's numbers all over the place. Like we might be looking at calcium here, which has a 20 up here for this number.
We might be looking for the mass.
But we could also be looking at the masses, and if we find, gee, let's see. Well, neon
would be the
over
closest
here
one.
has a 20 down here. So, Mr. Hunter, which one of those numbers, and here we go, which one of those numbers will we look at? We'll look at the 20 for calcium, or
As
the
we
20 for
defined
neon?
before, the atomic number is the number of protons. So we'd have to find the number of protons, which is 20. we'd have to find the element that has the number 20 as the atomic number. In this case, it would be calcium. We then want to write it out for its nuclear notation. So we take 20 plus 20. That would give us 40.
So this 20 plus this 20, so then we know there's 40 total massive particles in the nucleus.
And we know that its atomic number, of course, should be 20.
So we're dealing with calcium 20.
Now, if we want to take this question one step further, because you will see a question like this, let's say, Mr. Ferguson, I change that 20 electrons to 19 electrons. So if I take this number here, because you will see these, where they're going to change this number on you, and you still have the same number everything else. So we need to figure out something about the calcium. Something that we did mention before is that if an electron has a negative charge of 1 and protons have a positive charge of 1, you would take that 19 and subtract the number of electrons, take 20 and subtract the number of electrons. It would be 20 minus 19. That would give us a positive 1 charge.
There's one more plus 1 charge than there's much. So this would be the same exact notation because the number of, but we're going to add a little
plus 1
for the charge. So that wouldn't be a calcium atom anymore, it'd be a calcium ion.
We haven't talked about ions before, but you will see this type of question where they say, hey, I have this atom that has 29 protons and 26 electrons. Tell me its element and tell me if it's positive or negative or what about it. So you will see that. So I just want to bring it up now so you see it now and it's in your brain.
I also like that because then it still makes you pick out what's important here. What's important to decide what element it is the number of protons.
Exactly.
Because that's going to establish which one on the periodic table. If the number of protons is 20, I'm going right to the atomic number 20, and then I'll figure out the rest from there.
All right. So then look at the last example we have. It's barium-137. So we want to figure out the number of protons and neutrons, and we don't really need to figure out the number of electrons because we know what it is.
Protons is going to be 56, and electrons is going to be 56 because in this notation, the atomic number is written right there.
Mm-hmm.
And if I want to verify that, I can look over on the periodic table. 56 is my number. So the 137 is the mass number.
Yep, we need to subtract 137 minus 56 to get the number of neutrons. I must say your handwriting seems to have increased greatly, Mr. Ferguson.
Increased or improved?
Improved.
Okay, I've been practicing.
That's good.
I've been practicing. So that's going to be, I'm terrible at math in my head, is that 81?
That sounds about right, but you're asking the wrong person. Allow me to break out this handy-dandy calculator I have. 81.
Okay, good. I didn't have to change it. So, hopefully we've taught you how to recognize the different kinds of notation, how to use the periodic table together with the notation to figure out your number of protons, number of neutrons, and then the number of electrons.
And also potentially the charge. The charge will come up. I think some of our practices might have charges on them.
They may. So if and don't let that throw you off because it doesn't change the element, it just changes the charge.
Yep. All right. Is this our last slide?
I think it is.
All right. Well, have a good night. We have one more of these slides for you coming up later. But in the meantime, have a good night.
So once you finish watching the video, there are 3 post-video questions here which are going to ask you to apply
what you just learned.
What we just learned. That's right. So give those a stab, see how you make out, and we'll go over them in class tomorrow.
Good luck.